Hello and welcome. We are very thrilled to show you our heart disease prediction application that we've been working on for this database exam. The first things that we're going to go through is the databases, the business case, diagrams, our data access, and a website flow with a few demo cases. These three databases are our main databases for our system. First we use Microsoft SQL, then we have MongoDB, and then we have Pinecone. The next thing that we're going to talk about is our business case. So basically, our business case addresses two critical aspects of our system, which is a predictor model for the likelihood of getting a heart disease and a user access to a medication web shop. In our report, you can read further into these different cases, which is objective, market analysis, technology, challenges, and FERPS, which is a model we've been using to define our functional and non-functional requirements, which actually have been a central and guiding model throughout our development phase.
I will showcase the different database diagrams we have made for our application, and we have made an ER diagram to showcase our Microsoft SQL database structure. And then for MongoDB, we have also made a diagram to visualize the Pinecone vector database. We've made a table as it's pretty difficult to visualize a vector database. And lastly, I will show the systems architecture diagram that shows how all the different part of the system works together. Microsoft SQL is used as the main data store for structured data. For example, we have the health survey, which is the heart disease data we use for training the predictive models. Then we also have user informations and also the chatbot settings and configurations. And lastly, we also have the whole web shop as the products, the orders, order history, and so on. MongoDB is used to store our predictive machine learning models and also our files for embedding with the generative AI model. And for most of the machine learning models, they could be directly stored as the binary representation in the database, and we also have some different metadata. And then for the files and the chunks is for storing PDF or text files to use with the generative AI as a knowledge base. And a quick note is that for the random forest model, it was too big to be directly stored in machine learning models. So for that one, we used the model ID, which then refers to fs.files and the corresponding chunks. To represent our Pinecone vector database, we've decided to make a table as it's hard to visualize the vectors. So this table just shows a representation of how the vector embeddings would look like before we use them for our knowledge base for our generative AI. The systems architecture diagram shows how the different parts of our project works together. And to start off, we have the C# ASP.NET project that communicates directly with Microsoft SQL and MongoDB. And then it also used the Python Flask API that is used for machine learning specific tasks, where it connects directly to the Microsoft SQL, MongoDB, and also Pinecone. And it also communicates with an external API, which is the OpenAI API, which we use for generative AI models.
I want to talk about how we use the databases in our project, and in our C Sharp project we made a project for the databases called Data Access, and in this project we have a iData Access interface and the iMongo Data Access interface. If we jump into the code, you can see that for the SQL Data Access interface we have CRUD operations and methods to execute the stored procedures. And in this SQL Data Access class, we implement the methods for the CRUD operations and the stored procedures. And for the Mongo database, we also created an interface with CRUD operations, and then we needed to create some methods for uploading files and getting the files and downloading them and deleting them, where we had to use the GridFS driver in the C# project.
We've also decided to make a user flow diagram to showcase the user experience journey throughout our application. We've made one for the user and one for the admin, since admin has its own separate view and its own navigation bar, where the admin can manage users and things regarding the AI models. First page is a login screen where the user can decide to register or not. Since we already have a profile, we'll just sign in with a test profile. The first page that the user lands on is this web shop where there's all these different products, and we can decide to click in on some of the products. Let's do that. And here you can see all the product details for this specific product. You can decide to add it to a cart or whatever, but let's go back to the shop and let's try to add a new product to our shopping cart on your right side of the screen. So we'll just add it now, and now you can see it has been added to the shopping cart. Perfect. Next thing is we can go to the Heart Doctor. So this is our next feature, which is a chatbot. We can try to give it a prompt of something, and it will be replied to us. And on your left side, you can see your old chats. Next thing is the prediction page, where you can type in some different input fields. As a user, you can choose a prediction model, and then you can predict how much or how likely it is to get a heart disease. The last thing is the user page. Here you can edit your profile, and you can go through your password, change that, you can delete the user, but the page that we'll check out is this order page, where you can see your previous order history.
In our web application, we have an admin page where we have a lot of functions, and I want to start off by showing the knowledge base page, where you can upload files for the knowledge base. And when you upload a file, it goes into the MongoDB, and then when you press the train chatbot, then it takes all the files here, and then it converts it, it embeds the files and puts it into the Pinecone vector database. And the admin can also see when the chatbot was last trained, and you can also change the initial message and the base prompt and which model to use and the temperature of the model. When you press save, then it shows it has been saved also. And then the admin can also search for messages in the chat history, so you can search for something like a keyword, and then it shows all the messages that contains it. And you can also retrain the models here. We had 3 different machine learning models, and you can retrain all 3 of them. And you can also see we have a database management page where you can check the fragmentation of the database and see the fragmentation percentage of each index in the database. And then if it's below 30%, you can reorganize it, and if it's above 30%, you can rebuild the index. And besides that, we also have the web shop orders here for the admin, where you can see the order ID and the user ID, and when the order was placed and the amount, and then you can update it to complete it.
First user demo case we'll be going over is the web shop right here, which the user can access by clicking up here on the web shop. Let's say the user wants to find a very specific product on our website. He then has this whole list to look through, and if he wants to filter the products to more easily find the product he is looking for, he can then type in a specific manufacturer up here. So let's try something random. He can then also set a price range. So let's apply these filters and see, and as you can see, the manufacturer name matches in here, and also the prices are under the price limit. When the user then wants to check out and is done with purchasing different products, he can then press checkout over here. So for the next user demo case, we are going to be going over the heart disease prediction page, where if the user wants to know a % chance of getting heart disease in the future, they can go in and put in all these different parameters. So let's just put in some random stuff here, and you can then press the predict button to get a probability of getting a heart disease.